if an attack is initiated, although we had provided measures to keep the attack from happening, then we must be able to understand how much damage the attack has done to our network, and the countermeasures that we have implemented, how far they have been able to reduce the impact of the attack if they could not totally stop the attack. In this module, we shall understand a simple denial of service attack scenario. We look at a simple counter strategy, and then we'll perform its analysis. This analysis is going to establish a subtle relationship between the attack which takes place and the counter strategy we propose and the interesting findings we draw. So, DOS attack is actually an unstoppable transmission, undesirable and timely, which coincides with the packet transmissions and interactions with legitimate clients. So, DOS attacker is actually a talkative person who also happens to be unruly, unkind, and stubborn. Formally, the DOS attack is an attempt, a malified attempt, to make a machine or a network resource unavailable. This unavailability is meant to harm the usefulness or the serviceability of that particular machine for the users which are trying to access it. These DOS attacks could be temporary or could have an indefinite or a permanent damage caused. DOS attacks are implemented in a variety of ways. One of the most well-known DOS attacks is the transmission of TCP SYN attacks, TCP SYN messages. These TCP SYN messages attempt to create half-open state with the server so that the server runs out of enough resources, the processing power, the memory, to give access to it from legitimate customers. The other attack is the ping attack, in which the attacker involves the server in sending out ping replies by bombarding it with ping requests. These two attacks are based on communication. Likewise, in terms of computations, if a request is sent to a server and the server gets involved in processing the reply to that request for an indefinite period, it means the server has simply hung. This hanging results into the server crashing. So the first one is related to communication and the second one is related to computation. However, there is a significant overlap between the two. Changhua He defended his PhD thesis titled Analysis of Security Protocols for Wireless Networks. Here, he defined a simple TCP SYN flooding DOS attack in which N packets carrying TCP segments with the SYN flag set are bombarded onto the server. The server implements a simple counter strategy by deploying a queue. This queue receives the incoming packets, which could be legitimate packets or which could be the attack packets. These legitimate or attack packets could then be randomly dropped. So by chance, if an attacker's packet happens to be in the queue and the queue randomly drops the packet, the server is going to avoid an attack situation. But if the server is doing this in such a random way that it drops the incoming legitimate packets and passes the attack packets, it fails to prevent itself from the attack. So the random drop queue is of length q. The attack success probability is given by the expression. Here we see that the total number of packets that are being sent from the attacker is n. So for one packet that the attacker sends, this success probability for the attack is 100% and the failure probability is 0. And the attack failure probability is 0. It means the attacker does make its way to the server. In order to implement a counter strategy which is more robust, the queue length can be increased, and then this random dropping of packets is implemented on a relatively larger queue. Here we see on the x-axis we have the number of malicious messages, and on the y-axis the attacker successfully blocks the legitimate packets from reaching to the server and establishing handshake. So this relationship gives us the blocking probability for the legitimate packets by the attacker against the number of messages for different queue sizes. As we see here, that for queue size equal to 1, as the number of malicious packets increase, from 50%, the overall impact of the blocking probability starts to increase rather quickly when we increase the number of messages. It means that with just queue size equal to 1, it is very hard to implement a counter strategy successfully. So we increase the queue size. If we look at the other extreme, queue is equal to 10, here we see that with just one packet, the overall impact of blocking is very low. However, as the number of packets keep on increasing, even with a queue depth of 10, the server is not able to prevent itself from the attack. The overall conclusion that we can also draw from here is that although TCP SYN attack seems easier to initiate, we need really smart counter strategies.